The good news is we're on the last leg of the arduous day today, okay? We're getting close to the end. We've got a few more slides and one more exercise. And then we'll do a review of what the code we've written, and then you'll be free to go. So, we've got our list processing working, we've got our list, we've got our drills working for our groups and our suppliers, all well and good. Our buttons are working, so when we go into something, we disable save buttons and new buttons and all that kind of stuff. The same sort of code and the same sort of structure that's in the existing Toolkit application is being used, albeit slightly different coding, but in the same sort of places in our new WPF as our Toolkit one. And if anybody's tried it, if you set that Symphony running WPF back to false or remove it, it will go back to the Toolkit program. You've not changed, broke or altered the Toolkit program whatsoever. Then you select an item, we've got an input form on there. A couple of people ask questions about if I grow the window, why does the font grow? I've put all those fields inside a view box in the XAML. It just makes it expand to the biggest amount of size the window can have. It's nothing fancy, it's just something I added. It's just a standard WPF thing. So we've got the input form. You can't save anything, and the reason nothing saves is we've not done the validation. So now we have to validate the data before we put it into the file. And we're going to call the original or the existing change methods just like the Toolkit would. But we're going to change the change methods to suppress the UI. We don't want to bring up new message boxes because in theory, ultimately, we will have no Toolkit involved. So new message box and new message don't exist in the WPF world. You can have equivalents, we can code the equivalents, but they don't exist because it's a Toolkit routine. That's the sort of easiest way to think about it. We're back to the repository. The repository, we can define the methods, the change methods, the drill methods. We're now interested in the change method. We've utilized the drill method because we code generated the styles. Now what, if you looked in the style file in the XAML, you would have seen for the group and supplier that if we have assigned change methods, we do additional styling to enable us to bring up and move to visual states that will display our cups for our groups and our suppliers. Now we're on the change method, but again, it's code generated, it's all in the data object, and it's taking the information right out of the repository. The change method, its signature, what I mean by signature is the structure of the arguments for a method or a subroutine or a function. That's what we call the signature. That's defined by the Toolkit. Now, I can't change that, you can't change that, that's just the way. And these want to continue working for our existing Toolkit applications. Because just because this change method is used in this program, the chances are it could be used in dozens of different programs, hundreds of different programs. We don't want to break that. So we're not going to change this structure. There are some caveats. A data entered and A data stored, we can pass those in, because guess what? That's what's come out of the text box or whatever input control we've just used. Pending status, we can mimic that because we can pass through and say, well, we think it's invalid, but you tell us what you think. Input info, we don't pass that. We don't have that information, okay? There are a couple of things like field names and that we could put into there, and if need be, we will, but generally that's passed through as a null argument. We don't pass it because we don't have an input window. So the pointers that are used, because that field, input info tends to have pointers to what the field name is, what the field start is, what the field end is, things like that. We don't have that information because we don't have the input block associated with that field within the input window. So if you're using information like that, there will be code changes in your change method required. They're not insurmountable, but there will be changes required. But once you do those changes in one change method, they'll tend to be similar in most of your change methods, and then that ripples through your entire application, because once you've done that one change method, wherever it's used, it means it's going to work. Obviously, A data, that's the data for the record area, and then the program data.def, that's our input method argument information, which again we can pass through. So here's the validation logic then. If pending's okay, then the Toolkit said, as far as I'm concerned, this field's valid, because the way change method works in the Toolkit is if it thinks you've got an invalid data in there, so you've put a value of 10 into a field that can only accept 1, 3 or 5, then it will call the change method and say, I validated this, I don't think it's right, but what do you think? Okay, well, I'm just going to ignore you and tell you that you were right. Thanks for calling me anyway. Nice knowing you. But generally, if pending's okay, the toolkit said, yeah, I'm okay. It's always going to be okay from the WPF side. Symphony doesn't do that sort of processing. If Symphony catches it as being invalid, it doesn't then call your change method for you to have the right to override that status. It just says, you're invalid, thank you very much. So if pending's okay, we're going to read a record from the file. And as long as we find that record, life is good. If we don't, then in toolkit terms, we're going to put up a message box, stop the user in the tracks and say, you cannot proceed until you have confirmed that what you are trying to do is wrong, it's illegal, and I'm not letting you do it. It's a bit harsh, but that's the way things work, and that's the way the toolkits generally work. So we put this message box up, boom, stop the user. Okay, we're back to this again, the Symphony data object. This slide looks pretty similar, the top half anyway. We also have a event handler on there called execute change method. Okay, now you may not recognize this code. This is very C#-ish, but essentially it's the equivalent of add handler in Synergy syntax. And basically, if you have registered a change method in the repository and code generated your data object, it knows about that change method, the name of that change method. So execute change method assigns the method doChangeMethod_part, that assigns that method to that event. So when data in a data object changes for that particular field, that event doChangeMethod_part will get executed. That's all that's doing. It's just defining an event handler. So your event handler then, at the top, we're defining a delegate. Symphony defines these all over the place. And this is how you define an event. The event uses a delegate, so the consumer of the event knows the signature of the said event. The delegate doesn't do anything. It's not got a proc, it's not got an M return, it's no logic. You can't put logic in a delegate. It's basically defining the signature, the structure. Okay? So you're calling it, you're giving it a name, change method event handler, and you're saying the signature of this is repository name, which will be a string or RPS name, is an inbound parameter, and it's a string. The second is an in-out message data, and it's of type data changed message. Data changed message is something inside the Symphony framework that allows us to pass information about the current field that we're on and return the status of that. The public event then allows us to say the event name is change method, and if you want to register a handler against it, it must have the signature as defined by the delegate change method event handler. So that at the top saying what can happen and how it will look when it happens. The bit at the bottom is your code that says this is what will happen when that happens. Okay? So there's my doChangeMethod_part. So the top bit is saying this is what it's got to look like. This is the signature. So the signature of doChangeMethod_part has to match the delegate defined by this execute change method, essentially. So doChangeMethod, input message data, data changed, raise the change method event, which is defined at the event, pass in the structure name, similar to the RPS structure size constant that we code generate when we create a data object. We also generate in a constant called RPS structure name, so you can get at the base repository structure name that created that data object. And then this message data. And message data is essentially, it's a little class with properties on that say, this is the field, is it valid, and if not, what was the error? Very simple. That add handler then is similar code to 2 slides ago. So that was in .NET, in our ViewModel. Now we're into the boilerplate code. So this is the connector between the fancy framework stuff and the traditional Synergy program. So we're going to add handler, so when the change method gets raised from the view model, we're going to call it's going to call our doChange method, private method. Inside that, we're going to do an X sub r to our method name. That'll be the name of our change method. And notice the information we're sending through. So we've got the part data start and end. So that's the size of the field within our data area. We've got value entered, value stored. They're both the same. Pending equals 0, which means as far as we're concerned it's valid. You tell me differently. We don't pass the input info. Part data is the whole record area. And then program data is any input processing method data. Alternative then in the change method, instead of putting a U message up, we want to basically tell the data object that that particular field is valid or that particular field is not valid, and by the way, this is why it's not valid. So we're not putting big messages up, we just subtly be able to say this data object is not valid. From that point onwards, the view, the developer of the XAML, the view, can decide what it wants to do. If it then wants to put a big message up, it could do. But in our design, what we're doing is going to put a subtle bit of red on the field to say, visually give an indication that this field is invalid, and then hover over with the tooltip and it'll tell you, supplier details not found. So that one line of code raises all the various events, bubbles them up all to the view, and that will say, oh, this needs to be red, and that's all to do with that styling. That's not WPF out of the box. That's all the styling that we've created for each individual field that we've got. So that's change processing. One last little thing, the toolkit has a status bar, fabulous status bar, and you can specify the different sections with the vertical bars and that. You can do a whole lot more with a status bar and the equivalent in WPF. But because the toolkit's got a status bar, we're going to implement a very simple status bar. They look almost the same, to be honest. What happens is we have ESEC says put into the section, the status bar, this bit of text. Okay? We're going to say if we're running toolkit, we'll use ESEC. If we're running WPF, we're going to pass some information to the view model to pass on to the view. And we'll do that in this instance. So if we're doing toolkit, we use ESEC, and you'll see the lines of code where that is. Else, we're going to do PRG VM status bar text. Status bar text is a property on the view model. It's just going to be a string, and when you deposit something into it, it's going to raise an event to the user interface to say, I have changed, come and get me. In our view model then, we've got this very simple structure of code. M status bar text is a backing field. Lowercase m, it's lowercase because it's a private field. It's m because it's a member of a class. Status bar text is a string. And then we've got a public property, so it doesn't have an m, and it's not a member. So status bar text, so if we get it, we return m status bar text, and that's what the user interface will call. When we've raised a signal, raise property change, which is part of the Symphony Conductor view model, base view model, that if you looked at the code, it does extend. Status bar text, and that's the value. So that's the property we've added to the view model to be the connector essentially between a status bar, piece of text in the view, and our program in the traditional toolkit sense of the word. Very, very simple XAML. You can do a whole lot more with status bars, and that's where you'll see the progress bars when you're doing printing and all that kind of stuff. All the stuff that you can't do in toolkit. Status bar, tell it where on the grid row columns we've set up on the input form, XAML input form, and then we just got a simple text block there that data binds to that property. So when we raise property change, that'll come back, get the information and display it. And that is pretty much it. We've got this one last exercise. We'll do this exercise and then we'll walk through some code, and then I'm going to shut one VM down and bring up another VM, and I'm just going to give you a very quick look at what we did as a proof of concept for one of I think I'm right in saying it's probably one of the best customers in the world. Okay, so for this exercise, we're going to define this delegate event pairing that you've just seen on the screen. Bind the methods together between the .NET and our boilerplate and our traditional Synergy code. call through to the change method, suppress the UI in that change method, and signal back the errors accordingly, add the status information, and before you grab a coffee, I want to make sure they're all running, change the supplier and group, leave the field and all that kind of stuff, and watch the, it's only I think it's only the supplier and group that are validated, I can't remember, and you'll see them go red, and you get the, hover over them, you'll see the tooltips.